Hello, everyone. My name is Brian Lizarazo, and today my presentation is on Groovy, the programming language. So, what's the history of Groovy? Groovy was developed by a software developer named James Starshman around 2003. It was meant to fulfill certain things that Java could not fulfill, such as Java being a static language. Groovy, what makes it so attractive is that it is a fully dynamic language that fulfills certain roles and needs that Java couldn't. So then, what is Groovy and what is it used for? Well, as stated previously, Groovy is a dynamic programming language that was designed for a Java virtual machine. It has very similar features to Python, Ruby, and Smalltalk, but has strong syntax similarities to Java. It is a dynamic programming language with still static typing like Java, but with the flexibility of a dynamic programming language. This dynamic nature allows it to do tasks like scripting and automation, and with the concise and expressive syntax, it is also well suited for automating repetitive tasks such as file manipulation, system administration, or data processing. Groovy is also used for web development and making frameworks and web application development. Okay, so before I continue on with this presentation, it's really important to understand what it means for a programming language to be either dynamic or static. So as stated previously, what it means for a programming language to be dynamic just means that it's very flexible. So what does it mean for a programming language to be flexible? So for dynamic typing, there is type checking at runtime, which basically means that variable types are checked at the runtime, meaning that this information is associated with the values during the program execution. The association between a variable name and the actual object or value refers to could change at any time during the runtime. And variables change their type during the execution of the program, providing for more flexibility, but it can lead to more runtime errors if misused. So what makes static typing different is that variable types are checked at the compile time, meaning that type information is known and verified before the program even runs. This early binding association between a variable name and its type is determined and fixed during the compilation phase. However, while it is a more strict system, it does lead to less errors, as static typing can catch type-related errors early in the development process, reducing the likelihood of certain runtime errors, which is what a major disadvantage Groovy has over Java. As you can see on the slide, I do have two examples showing a Groovy program that shows how dynamic it is compared to a Java example of the same kind of sort, but showing off how it's static. So for example, in the Groovy example, I put def number equals 42. This is me declaring the variable without initiating its type. And then in the message, I put in quotes the number is the $number, which I'll get into later, which involves string interpolation. But this is to prove that the variable can change at any time during the program, whether it be from an integer into now a message or a string. However, in the Java example, with the same number and the same variable, we have to initiate it into an integer. Without this, we cannot run the program. And to include the number in the message, instead of using string interpolation as we do in the Groovy example, we have to use string concatenation, which means we just have to connect the message plus the variable and then output it in the system out print. However, even though in the slide I said that on Groovy is dynamic but yet has static typing, this is actually a feature done by Groovy on purpose for people who developed on Java to still seamlessly transition to Groovy. So static typing can be used for Groovy. However, it is encouraged to use its more dynamic and flexible nature to run more efficient and concise programming, but it is a seamless transition to go from Java or C to then Groovy. Okay, so for the next few slides, we'll be discussing the syntax of Groovy and its resemblance to other programming languages like Java. We will also be discussing the differences that Groovy has compared to these other languages and what makes it unique, what kind of grammar and syntax went into making Groovy. So as stated previously, Groovy closely resembles Java, and like I said earlier, this is done on purpose to make developers go from Java to Groovy seamlessly. So they share a lot of commonalities, such as a shared basic structure with such things such as classes, methods, and packages. And they use a lot of the same data types, primitive data types, such as integer, long, double, and boolean, and much, much more that we'll get into later. They are both object-oriented programs, which means that they support classes, objects, and most importantly, inheritance, and also recursion. And the way conditional statements and loops are structured are more or less the same. For example, look how for the Groovy examples, we define a variable to equal 10, or the way we capture a method, or the way we capture a catch case block. So here on this slide, we can also see through these two flowcharts how a while statement or a for loop in Groovy is also very similar to one in Java. As we can see, when a condition is done, there's an if else statement with a block within the if condition, and with the for loop, there's a condition, and when that condition is satisfied, an increment is then done, and then the process repeats until it ends. And here's just a list of what Java and Groovy both share in reserved words. Some of them function a little bit differently, but for the most part, all these words function the same in both languages. So while Groovy and Java do share the same reserved words and primitive types and a lot of syntax similarities, what makes Groovy so unique is its a concise nature. And I'm going to keep repeating that throughout the presentation, how it's very concise. As you can see in these examples, initiation is not required, and sometimes the option of a semicolon or certain brackets aren't needed. Groovy allows developers to declare and initialize variables in a more concise manner, especially when dealing with collections, while Java, having the same equivalent code, will be more verbose and more lines of code just to do the exact same thing, which I'll show later in the next slide. Groovy has more concise syntax for closures, and this is particularly useful for DSLs, which I'm going to get into later. So on this slide, there are two examples, the top one being Groovy and the bottom one being Java. These two programs function exactly the same in the sense that they produce the same output with the same input as seen in the program. While Groovy and Java, like I said earlier, share similar syntax and similar operators and similar formatting, it is clear as day that the concise nature of Groovy and how concise it is apparent when you compare the same function in each of their own programs. In the Groovy program, there's only 6 lines of code used to print out the original numbers as listed in the array and the output, which is the squared version of those. Groovy supports list-like operations, such as using the spread operator to include elements from another list or array, while Java, to achieve the same result, would require more code and lines to achieve the same result. Groovy also provides concise syntax for creating arrays with a range of values. Groovy also allows for concise array-related operations using GDK, or the Groovy Development Kit methods. Groovy provides a more convenient and concise syntax for working with arrays, initializing, and operations and manipulation. The syntax enhancements of Groovy that's not seen in Java is more expressive and much better for developers with dealing with arrays compared to the much more complex and redundant syntax of Java. Lastly, we're going to talk about DSLs, or otherwise known as domain-specific language in Groovy, and what kind of things can be achieved when using DSLs in Groovy. So how this functions is that Groovy uses closures, which are blocks of code essentially that can be assigned to variables and be passed around. Closures are basically the foundation for defining DSL blocks in Groovies. This leverages delegation, allows methods invoked inside the closure to be delegated to another object, which then afterwards enables a DSL to be created by defining methods inside a closure and properly delegating them in the context of the program. This allows for more accessible readability from programmers, showing their programs to other programs for them to easily read it. This expressiveness allows for DSLs to closely match the problem in the domain. And the ease of configuration are commonly used for configuring settings, providing a natural and intuitive way to configure applications. So let's look at the example on the slide. So first, we define a simple person class with two properties being string, the name, and the integer variable age. And with the toString method, we can provide a custom string representation of the person object. Okay, so not only do we have now our class in our toString method, we also have this program also shows a person builder, and it's responsible for constructing the person objects. Then lastly, we have the build method, which implicitly invokes the construct person object with the properties as stated earlier. As you can see, this simple program that I'm showing in this slide of a domain-specific language uses a lot of object-oriented programming principles and a lot of aspects from that side of programming as seen in Java. It uses a lot of encapsulation, which is a bundling data, attributes, and methods that operate on a data into a single unit known as an object, which we saw in the person class. While DSLs and object-oriented programming can be used together, do not get it confused, they do serve different purposes. Object-oriented programming is a paradigm for organizing and structuring code, while DSLs are specialized languages designed to be expressive and readable within a specific domain. However, the use of DSLs within object-oriented programming codebase can enhance the readability and expressiveness of certain tasks, which in turn go hand in hand with each other and are often seen together. Since we're already on the topic of object-oriented programming, I thought I'd give a refresher and example on how it works and how it works in Groovy. So what is object-oriented programming again? Well, basically, the way it works is that we use objects that are instances of classes and that represent real-world entities. Each object has certain properties, attributes, and behaviors that will be explained within the code through methods or functions. This will have classes which are blueprints for creating the objects, and it will have properties as stated previously and behaviors. So let's break down this example that I have on the slide. And just from first glance, since you can already see some static typing and a lot of similarities to Java, some people wouldn't even be able to tell that this is a Groovy example upon first seeing it. Because the way object-oriented programming works is very similar to Groovy as it is in Java. But let's explain the code right now. So first we have the employee class, which is defined by two properties, as you can see, employee age and employee name. And the method we use in this program is the display employee info, which is a method that is defined by the employee's name and age using the println and string interpolation with the $sign, as you can see. Then after, an instance is created using the employee1, which is a constructor which calls the properties within the parentheses, which in this case is Jane Smith, and the number 30 to initialize the properties. So yeah, that is the end of the explanation for the program. In summary, this code demonstrates the basic principles that everyone should know about object-oriented programming, like in Java, but instead in Groovy. This shows the class and instances and properties like you would see in these object-oriented programs, except with the dynamically typed language nature of Groovy. So in conclusion, Groovy is a fascinating and great language that complements Java and many of its shortcomings that it faces for being a static language. While Groovy might be an unpopular language with a niche community to support it, it is a very versatile language for the JVM, blending scripting and the reliability that of Java. Its syntax enhances developer productivity because of how dynamic it is, making it suitable for scripts on a large scale. Groovy is obviously most notable for being integrated and going hand in hand with Java and being a smooth transition to jump from each of the two languages. And as stated in my presentation and other videos, it is also known for its domain-specific languages. With features like closure and dynamic typing, Groovy remains as a great option for developers to seek something that they like in Java, but with more flexibility, power, and just overall expressiveness that is not found in Java.